Hi, this is Mr. Kingsbury, and today we're going to do a few more examples of how to solve an absolute value equation. Remember, when you do this, the first thing you have to do is get the absolute value bars by themselves. Then you write two different equations without absolute value bars. You solve them both, and then you check your answers. Now, there are 6 questions here, but in the interest of keeping this video short, I'm going to do questions 1, 3, and 5. I will post the completed notes on Schoology so that you can see all 6 of them worked out. So let's start with number 1 here. We have 3/4 times the absolute value of g minus 5 plus 6 equals 2. I need to get this part by itself. What I'm seeing is that the absolute value of g minus 5 is being multiplied by 3/4 and having 6 added to it. So I need to undo those. I will undo plus 6 by subtracting 6. 2 minus 6 is negative 4. 6 minus 6 is 0. That leaves 3/4 times the absolute value of g minus 5 on the left and negative 4 on the right. Now I need to undo this multiplication by 3/4. So the opposite of multiplying by 3/4 is either dividing by 3/4, which you can absolutely do, or multiplying by 4/3. I'm going to go ahead and multiply by 4/3. So I will make this a fraction by putting it over 1. I'll multiply it by 4/3. Over here, this becomes 1. And it just leaves me with the absolute value of g minus 5. On the other side, I have negative 4 over 1 times 4 over 3. Negative 4 times 4 is negative 16. 1 times 3 is 3. So I now have my absolute value equation with just the absolute value piece, which is exactly what I want. So I'm going to set up the two different equations. Remember, one of them looks exactly like this. The only difference is we drop the absolute value bars. The second one will look just like this, but we are going to change all of the signs on one of the sides. And in this case, the right side that just has a single number is easiest to change. So I'll write positive 16 over 3 instead of negative 16 over 3. And actually, to solve these, I will do the same thing as you see, or as you will see. So we've got g minus 5 equals negative 16/3. All I'm going to do is add 5 to both sides. That makes a 0 pair on the left. G minus 0 is g. And then on the right, we've got negative 16/3 plus 5. That's actually 5 over 1, which if I change it into thirds becomes 15 over 3. So I have negative 16/3 plus 15/3. That's negative 1/3. So we'll see if that is correct or not. We'll check it in a minute. Same deal over here. I'm going to add 5 to both sides. Once again, on the left, that makes a 0. Once again, that leaves me with just g. On the right side, we have 16 over 3. And again, I'll turn this 5 into 5 over 1. And if I adjust the denominator so that it has a denominator of 3, this becomes 15 over 3. So I have 16/3 plus 15/3. Here's the difference. Over here, one was negative and one was positive. Over here, they're both positive. So when I add them, I get 31/3. Now the question is, are those correct or not? Or are they values that don't work? Are they extraneous? So I need to take both of these and plug them back in the original equation. So I will do that now. So we will have 3/4 times the absolute value, sorry, I meant to put a bar, not a parenthesis, of negative 1/3 minus 5 plus 6, and hopefully that equals 2. We'll see. So 1/3 minus 5. Again, I need to make this thirds, so I will make this 15/3. So I got negative 1/3 minus 15/3. That ends up being negative 16/3. Remember, you just do one side following PEMDAS. I'll take the absolute value of negative 16/3. That would be positive 16/3. And when I multiply 3 fourths and 16 thirds, something interesting happens. If you want, you can go ahead and multiply this. You get 43 over 12. I'm sorry, 48 over 12, which is just 4. I'm going to do this. I see that these are both divisible by 3, so I can reduce them to just 1s. And 4 and 16 are both divisible by 4, so I can do this. And I end up getting that 4 that I was thinking of. 4 plus 6 is 10. So on the left side, I have 10. On the right side, I have 2, which I will just copy. And that leaves me with the statement 10 equals 2. Is that true? Absolutely not. Which means this is an extraneous solution. Let's try it with the other one. We got g equals 31 thirds. So we'll see if this works. 3 fourths times 31 thirds minus 5. And I might as well make this 15 thirds while I'm thinking about it. Whoops. This is supposed to be an absolute value bars. I did it again. And that equals 2. Again, when you're checking your work, you're not adding, subtracting, multiplying, or dividing things from both sides. You are following PEMDAS on each side separately. So I'm going to deal with 31 thirds minus 15 thirds. That would be 16 thirds. And I'm going to take the absolute value of that, multiply by 3 fourths, and add 6. Let's see. The absolute value of 16 thirds is 16 thirds. And once again, I can do all kinds of cool cross-canceling. 3 and 3 are both divisible by 3, so that simplifies to 1. Both of them do. I can divide 4 by 4, and I get 1. 16 divided by 4 is 1. Whoops, is 4. So I end up getting 4 plus 6 again, which is 10 again. So on the left, I have 10. On the right, I have 2. I will copy that. Is 10 equal to 2? Absolutely not. So neither of these work. So it looked like we had 2 solutions, but it turns out neither of them work. So we're going to have to say no solution. Very important. Let's try another one. Here's number 3. We've got 2 times the absolute value of, I'm going to use x instead of lambda. X plus 7 minus 3, and that equals 8 lambda plus 3. So what I'm seeing here is there are absolute value bars on the right, or on the left, excuse me, and that they are being multiplied by 2, and we're subtracting 3 from them. I don't care that there's an x over here. That doesn't bother me in the slightest. We'll attack that later. Right now, not a big deal. So let's start by adding 3 to both sides. On the left, that makes a 0 pair, and I'm left with 2 times the absolute value of x plus 7. And then on the right side, I have 8x just comes down. 3 plus 3 is 6. Okay, next up then we need to undo this multiplication by 2. The opposite of that is division by 2. And I'm going to divide both of these by 2 separately. Some people put one line with a 2 under it. That's fine. Just handle it appropriately. I find that a lot of times when people just put one division sign and one denominator, they don't handle it well. And they end up not simplifying things that they should. Speaking of simplifying, 2 divided by 2 is 1. 1 times the absolute value of x minus 7, or x plus 7, is the absolute value of x plus 7. So we got that by itself. Over here, 8 divided by 2 is 4, so 8x divided by 2 would be 4x. And then 6 divided by 2 is 3, so we get 4x plus 3. Now we have to set up both of our equations, right? So the first one will be exactly what you see here. 4x, I'm sorry, I did that wrong. X plus, let's start over. X plus 7 equals 4x plus 3. Now you see why I prefer to use a pencil. I've been told, though, that pencil's hard to see, so we're using pen. The other one will look just like this, but we're going to change one of the sides. Now, in this case, there's not really one that necessarily is better or worse than the other. Both sides have 2 terms. So I'm just going to change the right side, just kind of be consistent. So we got x plus 7 equals, I'm going to make this negative 4x minus 3. And then we'll solve. So I'm going to subtract x from both sides. That makes a 0 pair. 0 plus 7 is 7. And that's going to equal 4x minus 1x is 3x. Bring down the 3 plus 3. Then I will subtract 3 from both sides. And I get 4 equals 3x. That makes a 0 pair right there. I should have noted that. And then lastly, I will divide both sides by 3. So 4/3 equals x. Let's do the same thing over here. I will subtract x. So that makes a 0 pair. 0 plus 7 is 7. Negative 4x minus x is negative 5x, and we'll bring down the minus 3. Actually, let's now add 3 to both sides. So we get 10 equals, and then that's a 0 pair, negative 5x, and then I will divide both sides by negative 5. I get negative 2 equals x. I'm sorry. I think I said negative 5, but I meant negative 2. I wrote the right thing. The question now is, do either of these work? Well, let's plug them into the original equations and see what happens. Or the original equation and see what happens. So for this one, we will get 2 times the absolute value of 4/3 plus 7 minus 3. Hopefully equals 8 times, oh man, times 4/3. Plus 3. That should, oh, and this is not absolute value, so I don't know why I was doing that. There we go. Alrighty, so we'll do each side and see what happens. So we got 4/3 plus 7. If I make this into thirds, it's 21/3. So 4/3 plus 21/3 is 25/3. And we're multiplying that by 2 and subtracting 3. The absolute value of 25/3 is 25/3. I multiply that by 2, I get 50/3. And then we're going to subtract 3, which I will rewrite as a fraction with thirds as the denominator. That's 9/3. So 50 minus 9 is 41/3. We will see what happens on the other side. And I'm also concerned that I have run out of room to be able to check the other number. It's okay, I'll do it on the back. On the right side, we have 8 times 4/3. That's 8 over 1 times 4/3. That would be 32/3 plus 3, which I will adjust. I will make that a fraction with a denominator of 3 by putting it over 3, multiplying the fraction by 3 over 3. 32 plus 9 is 41, so I get 41/3. And I will write that all the way down, and look at that. 41/3 equals 41/3. That works. So 4/3 works. Now the question is, does negative 2? And unfortunately, I've run out of space. So that works. I've run out of space, so I guess I'll turn it over and do it on the back. Here goes nothing. So we're going to test negative 2. So we got 2 times the absolute value of negative 2 plus 7 minus 3. And hopefully that equals 8 times negative 2 plus 3. Alright, so we'll just do each side separately and see what happens. Negative 2 plus 7 is 5. So I got 2 times the absolute value of 5 minus 3. And the absolute value of 5 is 5. So I end up with just 2 times 5 minus 3. 2 times 5 is 10. 10 minus 3 is 7. On the other side, this will be a little bit simpler. 8 times negative 2 is negative 16. And negative 16 plus 3 is negative 13. So the end result, our final statement is 7 equals negative 13. Is that true? Nope. Which means negative 2, not a solution. So there's just one solution there. All right, lastly, we have number 5. The absolute value of, it uses mu. I'm going to use x. So the absolute value of x minus 4, x plus 4, sorry, equals the absolute value of 3x. So let's take a look at that. Absolute value of x plus 4 equals the absolute value of 3x. Now, this is really cool. What I like about this one is there's nothing outside the bracket or the absolute value bars. Nothing. So we don't have to worry about moving things to one side or the other or any of that business. We can just jump right into rewriting it. Pardon me. So one equation will be just x plus 4 equals 3x. The other one will be x plus 4 equals negative 3x. And yeah, you could change the left side if you want, but that's 2 terms that you'd have to change instead of 1. Now let's solve this. For this one, x plus 4 equals 3x, I'm going to subtract x. That makes 0 pair on the left. 0 plus 4 is 4. 3x minus 1x is 2 x's. So I have 4 equals 2 times x. You undo multiplication with division. So I'll divide both sides by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. It simplifies out. So we'll just put that in. Simplifies out, and this equals x. Let's try this other one over here. I'm going to subtract x as well. Makes 0 on the left. 0 plus 4 is 4. On the right, though, because I have negative 3x minus 1, it's going to combine different. Remember, previously it was positive 3 minus 1. Now it's negative 3 minus 1. That's going to get us a negative 4. So I have 4 equals negative 4x. I will divide both sides by negative 4. On the right, the negative 4 is simplified to 1. 1 times x is x. On the left, 4 divided by negative 4 is negative 1. Now we got to check these. So let's go back to the original equation and plug in the 2. Absolute value of 2 plus 4 hopefully equals 3 times the absolute value of 3 times 2. Those are supposed to be bars. I'm getting kind of sloppy, sorry. 2 plus 4 is 6. The absolute value of 6 is also 6. 3 times 2 is 6. So we have the absolute value of 6, which is 6. And that gives me the statement 6 equals 6, which is 100% true. So 2 is absolutely an answer. Here's hoping negative 1 has a similar result. So we will do negative 1 plus 4. The absolute value of negative 1 plus 4, I'm so sorry, equals the absolute value of 3 times negative 1. So let's do the left side. Negative 1 plus 4 is 3, and the absolute value of 3 is just 3. On the right side, we've got 3 times negative 1 is negative 3, and if we take the absolute value of that, we get positive 3. So we end up with 3 equals 3, which is 100% true, which means negative 1 is also a solution. That's awesome. So now you've seen an example where there was no solution, where there was one solution, and where there's 2 solutions. Again, I'll post the rest of the examples in Schoology. Have a great day.